Let us now continue our discussion in topic 3. We are to evaluate the response of the first order using poles. So if the system's step response, it can lead to a representation even though the inner construction is not known. In other words, kahit hindi natin alam kung ano yung system natin, kung ano yung construction niya, kung anong klaseng system siya, kung amplifier ba ito, or RLC circuit, or whatever type of system, okay, we could arrive or we could solve into its representation. No, it's either in time response equation or ultimately in its transfer function if we have the system's step response. It's the curve. Maybe we could get it from an oscilloscope, no, through experimentation. With the step input, we can measure the time constant and the steady state value from which the transfer function can be calculated. Let us consider a simple first order system, the GS equal to K over S plus A, whose step response would be, so our output transform C of S would be equal to K over S quantity S plus A. We can actually write it as C of S is equals to K, and that could be equivalent to 1 over S times S plus A. And by partial fraction, we could have it this way, no? So C of S equal to K times 1 over S plus 1 over S plus A. Okay? So by inspecting, we could solve the values, no, of the, or rather we have here say K1, or say we have here A and we have here B. So C of S could be equals to K times that will be if we let S equals to 0 and then eliminate this, is 0 plus A, so that will be 1 over A. Okay, so meaning that will be 1 over A. And then if we have S to be equals to negative A, so we eliminate this part. So this S will be equals to negative A, so that will be 1 over negative A. Negative A, okay, the coefficient. Okay, and of course we have here, by the way, the S, and we have here the S plus A. So therefore our CS would be equals to K, no, K over A S plus or rather minus, no, it's minus K over A over S plus A. Okay, so eto na nga yun, ano, yung ating output transform. Then, if we can identify the value of K and the value of A from laboratory testing, we can obtain the transfer function of the system. Okay, now with assuming, no, this is the step function response output, response curve of our given system. Okay, so it's a step response with a 0.7. Excuse me for a while. Okay, so we've been saying that this is the given curve of our problem, wherein the final value is at 0.7. Okay, so this is a unit step response, and we're going to determine if this is a first order system with no overshoot and non-zero initial slope. Okay. By the way, when we say no overshoot, it's a proof, that it's a first order. Likewise for the non-zero initial slope. And by inspecting through this graph, the test result of the system from the oscilloscope display, now we're going to measure the time constant, that is the time for the amplitude to reach 63% of its final value. So we're going to inspect this graph, okay, and try to locate the 63% of the final value. So if the final value is it's a 0.72, okay, so what is 63% of 0.72? So that is 0.45. So from here, say ito yung ating 0.45. Okay, the 63% of 0.72, which is equals to 0.45. So where it falls in the time, okay, this one. So the TC, or the time constant, which is 1 over A, would be equal to 0.13 approximately, or right here. Okay, so as you could see, we are only approximating this value, and hence our the value of A, which is equals to 1 over the time constant, substituting the value of 0.13, we will get A to be 7.7. So from here, from our formula of the output transform CS, and let's recall the time response CT, and notice that the K of A here is the coefficient of our input or forced response, and the C of N of T, which is equals to K of A, this one, is the natural response. And therefore, the steady state of 0.72 is equal to K over A. Because again, this numeric coefficient is the amplitude of the force response. So, from this equivalence, therefore, if we transpose A on the other side, K will be equal to 0.72 times A. And since we have identified A to be 7.7, therefore K is 5.54. And therefore, writing the value of K and the value of A in our equation of the output transform, so therefore, the transfer function of the first order with no overshoot and initial slope and this non-zero is given by this. This is rounded off. Take note that we estimated our time constant, which is 0.13 earlier.